So for the gas addition kit, a couple of pieces that we need to go over. The attenuator system works similar, but the pressure system works a little bit different. So with this, the pressures is actually built into the top and is actually going to be read through a pressure device inside the system, as well as there's a gauge up here that's reading pressure. So in order to put this all together, once this is locked down, the attenuator will not lock in place. There's actually a little knob right here that will prohibit you from doing so. So if it's all put together and you try and lock it down, it won't. I don't believe it'll work. Yeah, it's not letting me do it. So what you have to do is separate the pressure device, which is just this Teflon screw. Take 5 returns. And this also, you need to be careful, this contains the thermal well that has the fiber optic probe that measures the sample temperature. But from here, this will lock down in place.
Sorry, quick question. Why do we need that?
Good.
Yes.
Yes, this is for the gas addition kit, yes.
Oh,
Yes, so I'll explain kind of how that works as far as that.
nitrogen or argon or something?
Right, well, I'll kind of discuss. I'm going to go into the physical and then I'll kind of do applications, if that works. So from there, the vessel itself is actually just a standard 10 mil vial. So you can reuse it if you want or replace it if it seems to be going through wear, but nothing different than this and than the other ones. The only difference is you won't need to cap this. So you'll put your sample together, place it in the attenuator, and then grab this pressure device, slide it down in, and then you'll stir. I recommend holding on to the kind of beige part and then spinning the bottom screw and pretty much keep going until it hits, and even then a good couple quarter turns just to make sure everything is sealed down. And then from there, now you're good to go. Now, the difference with this system, again, quite a bit of extra steps. You'll actually have to go into the keypad here, hit the home button, go down to system setup, temperature type, and you'll need to change that to fiber optic. Once I hit enter, temperature type is set. I can hit home, it saves it. Home again, and you're taken to the top screen. From there, my vessel's ready to go. I put in the fiber optic probe.
How often people break this fiber optic?
Far too often. So,
Are they hard to replace?
hard to replace? No. Expensive? Yes. They're about like $500 each. So, want to try and be careful. Now, good and bad news. The good news is this between here and here, the sort of floppy part is pretty resilient. You don't want to do a very large or small kink, but it can bend pretty frequently and you'll be fine. It gets a little bit darker blue down here at the end. This part you want to try and keep as straight as possible. Otherwise you might have potential erroneous readings of your temperature. And then temperature is read kind of towards the very end here at the tip. So it's a little tricky. So once you push it down, there is a little bit of the darker blue section which is sticking out, so it might be possible to bend it down about from there to there. So you want to be careful of not bending that over. Again, it's just one of those things you gotta just have to take special care. Usually I recommend whenever you're done using it, trying to keep it as far away as possible. If that means taking it out and putting it back in the box, that might make sense. Otherwise, what I usually do, as long as there's not a bunch of things back there that could hurt it, just kind of put it behind the system, and then you should be good to go. But entered in. Alright, so, and then for those of us that can see the computer,
Can I ask you a question?
so actually you can see the fiber optic probe inside there.
When you're done with this gas addition kit and you go back to normal, do you also need manually switch the temperature?
You do. The good news is the system will kind of stop you before you do that. So if I swapped everything out right now, put in one of the other attenuators and tried to run a 10 mil reaction, it would say, error, you're using fiber optic, do you want to change temperatures? And you would just say switch to IR right there, and then it would do it. It may give an error on the computer. Likely, I'll test it out before I leave. Likely, it will tell you that the temperature is wrong, and then it's quickest just to go back here, change it on the system, and then try the reaction again on the computer. If not, it might just give an erroneous error, and that's kind of one of the first things you guys should check is, oh, is it fiber optic still turned on, kind of thing. But likely it'll tell you fiber optic is what's being used. So, yeah, excellent question. From here, there's not much of this that you would be interacting with during a normal run. So, right here on the left-hand side, this is the airline to the vessel. On the right-hand side, this would go to the gas source. So this would typically be something like hydrogen. Mostly what this is used for is a gaseous reagent. So something like a hydrogenation, something like that, where you're actually consuming the gas as part of the reaction. That's what this is used for. So what you do is you'd hook this up to the gas source. It would pump it into this little panel, and then the panel would allow you to pump it into your system. So what you'd be doing when it's on run, that means the system is allowed to turn on the microwaves. It also means it's sealed from doing any either adding or venting off whatever your gas is.
So like how does it balance the pressure? Let's say if we are using, I don't know, hydrogen gas and we are like adding amount that we don't need, like let's say like high speed hydrogen flow. So how does it balance the pressure?
So the way it is it's not a continuous flow, it's a charging system.
Okay.
Yeah. So what you would do is you'd run it, go from run, you'd say fill. It would essentially fill that up to about 200 psi, which is the upper limit of the pressure when you're doing this. And then you'd go to run. So now the system is charged with the gas. You run the reaction. Oftentimes, depending on what you're doing, either you're going to, the pressure's going to go down. So even though the temperature is going up, you're actually consuming that gas in the reaction. So your pressure will go down. It may go back up once your temperature reaches a certain point. But again, most of those reactions are not very high temperatures, so you're not doing a ton of vapor pressure. So it'll go down. You have the option then of pausing the reaction, the microwave, coming back here, filling, charging with more hydrogen or whatever the sample gas is, going back to run, and then running the reaction. And then once everything's done, you'll do cooling. And then from there, if you want, you can vent in the case of if there's any kind of other sort of off gas. This goes to a vent line in the back, which we usually recommend putting into like a beaker or something, typically with like methanol on the bottom. So if it needs to, the bubble kind of captures by the beaker. But right now I just kind of have it free floating.
How safe the hydrogenation reactions for this particular device?
What's that?
How much safe hydrogenation reactions? Dehydrogenation, hydrogenation.
How much hydrogen is safe?
The ATM pressure, how much pressure is, safety purpose for the 5 ATM or 10 ATM pressure?
So everything ends up getting regulated through the box. So whatever your source is pushing out, it'll go into the box, and then you usually pressurize it. The way this tubing works, this one is actually, the inner diameter on the charging line is actually very, very small. So you really can't kind of overload the pressure. Everything will kind of get stepped down inside this system. And then once you're filling it, as I mentioned, you're pretty much only going to be able to go up to around 200 psi, and then after that, it kind of like blocks it off. And then you'd go to run and go from there.
Does
that make sense? Okay. Sorry about that. But yeah, and then so that's pretty much it. So then once you've system is cooled down, you can vent off, and then click it back to run, and then kind of everything in reverse. So take out the fiber optic probe, unscrew the pressure device, then you have access to your sample, or just undo the attenuator and then grab your sample from there also. So like I said, a couple extra steps, but if that's the does give you access to those reagents. Now, as far as your question in terms of running inert gas, like nitrogen or argon or something like that, it would certainly work, but as you've noticed, I'm interacting with the sample quite a bit. Oftentimes, this is still interacting with regular air. And then so I could do all that and then fill with nitrogen or argon, you kind of have it pressurized, and then run it. The problem is this will typically fill it as much as possible, so you're going to charge it with a lot of nitrogen or argon. If you're running a reaction that does go past the boiling point, you're going to be generating even more vapor pressure. So it's going to kind of cause a problem there.
You can still purge it, as you said, because it's in a sealed
yes,
environment.
yeah. So you could just fill, run, and then just try and do like a quick fill and just get a little bit in there. But otherwise, as I mentioned, what I recommend is the vials, because again, they seal completely atmospherically with the caps on by themselves. So from this point, they're completely sealed. You can purge these, like you can pierce the caps, purge them if you want to, and then once it's placed in the system and this pressure device moves forward, then you're looking at, again, up to 300 psi, and you'll be good to go.
So when we are using this one, the programming on the computer is the same, right?
Yeah, so programming, everything would be the same. You are going to be limited. You have to sort of remember that you're limited to 200 degrees Celsius and 200 psi. So if you go in and program something at, let's say, 150 degrees Celsius, you're going to be fine. If you go in and program it at 220, you'll try and run it, and the system will say, I can't reach that temperature. So you'll have to sort of remember those limitations, but otherwise you can program everything here and then run it just fine. Typically with those reactions, I would just recommend kind of running it from the panel, just to sort of keep everything in here, but you certainly can, and that way you have all the data as well. So good question.
Are you done with this part?
Yeah, so that's pretty much it on mine, unless anybody had questions.
For people who is on a computer and who just arrived, could
Yeah.
you please explain the limits on the air?
So right now, we don't have the air connection. Hopefully that'll be like remedied. Short term, what that means, the system will still run just fine. Post-reaction cooling is going to be a lot slower. So normally what you'd have is, you heat your sample up to 200 Celsius. You'd have the air blowing on it. That would cool it down to 60 or 50 degrees, typically under 5 minutes. Without the air, it's sitting in kind of a hot chamber, and so it takes a lot longer. Might increase it about 15 to 20 minutes, something like that. So just something to prepare for with your samples. Hopefully it's not too much of a detriment, but it can definitely be annoying when you saw something on the computer and now you're waiting like another 10 minutes for you actually have access to it. But hopefully once there, the pressure on this system is usually about 20 to 30 psi, and I recommend just house air because it's blowing on the outside of the glass, so it's not interacting with your sample at all, so you don't need to worry about any kind of contamination. It'll just be blowing right on there.
You probably said something about it, but what if I just installed air pump on the bottom that can replace the house air? Can it?
Yes, absolutely. So if by air pump, like an air compressor, something like that, most certainly. So the required pressure is very small. 20 to 30 psi is pretty minimal. So a standard, even small tank air compressor could do it. And if you want to put it under there, they actually make some silent ones that run under 60 decibels, which I think is lower than like a conversation volume. So you might hear it kick on every once in a while, but it shouldn't be something that'll distract you or blow your ears out or anything like that. And again, you don't need a very large tank. The larger the tank, the less it's going to kick on whenever it does need to use air. But it does use a pretty significant, because it's about 30 psi for something like 5 minutes. So I usually recommend, if you're going to have to be going through bringing in air tanks, just get a compressor, because honestly it's going to be less hassle long run, and you're going to be replacing the tanks probably more frequently than you'd like. I know those things are heavy to roll around, so
Right.
that's usually what I recommend.
So if you don't have it,
If you can't get access to in-house air, I'd go to Home Depot or something like that, or even order them off Amazon, and just silent compressor, and you'll usually be able to find something pretty easily.
Okay. Yeah. Any questions? You guys, any questions that you can ask? Chaturya, Patrick?
I think for now
Fair enough. Now, that all being said, we do have a dedicated team of in-house chemists at CEM. So if you guys have any questions about either the system functionality or even a reaction you want to run, I'll have Marina distribute my email. So any questions you guys have, just shoot me an email. Let me know where you're from, so that way I can make sure I know what kind of system you guys have. And then, you know, any kind of questions you have, if I can't answer it directly, I'll try and get it to my team to answer any kind of specific questions to help you guys, you know, get moving with what you want to do with it. So.